Perfect. My name is Thomas Tschickardt. I'm happy to present to you my topic about the Lean and BIM-based flight planning for automated data acquisition of bridge structures in particular with LiDAR UAV during construction phase. I work as a digital construction manager for Freytag Ingenieurbau, quite a large construction company in Germany. I'm responsible for our BIM competence center, BIM management and coordination, so I coordinate all our BIM managers. But also I'm a PhD student at Technical University of Kaiserslautern, where I do some research with Fabian, who had the Best Paper Award. My motivation, since I'm a civil engineer and I work quite a lot with my colleagues on the construction site, is that in the project phase, the development and the design of the BIM model is actually quite interlinked with the project, which you can see with the yellow green chain. So the BIM model is actually really good used in those phases. But when it comes to the construction phase, actually a lot of colleagues, not only from Freytag but also from other construction companies, they don't use the BIM model anymore because it's not practical, it's not following the processes, etc. So all these data sources, you can see it here in red, the construction diary, for example, quantity reports, delivery notes, etc. They are information sources, but they are not getting back into the BIM model, which they should. Because the target is actually the as-built documentation, so we do get a as-built model after the construction phase, which you can use then for the operation and maintenance phase, which is also not quite interlinked with the BIM model. So the integration of those information is actually quite labor-intensive, error-prone, and inefficient because, as you can imagine, you have to go out even with an iPad, which is already digital, but you don't put the information back into the BIM model, which is quite sad. I hope you agree with my opinion. Even though we lose a lot, we are losing and missing lots of data. Because you can imagine, even if I punch something into my iPad, it doesn't get back into the project data. So the problem statement actually is in infrastructure, in bridge engineering, we do have quite complex and heterogeneous projects because due to the one-off production, every bridge is different. We do have 40,000 bridges in Germany. Some are quite similar, but of course they are still different. The data acquisition and the construction progress is actually still being done manual and laborious, even though there are some research where you can automatically done that, but usually it takes up to 1 week in 65% of the cases to get back the information from site into the office for a rapid decision making. So if you want to do a rapid decision making, like we do have to change the time schedule, it's quite complicated. The manual planned data acquisition, as we know by tongue and biswas, they lack of accuracy and coverage, which also lead into no quality criteria, into LiDAR-based drone acquisition. They have done the research for terrestrial laser scan, but we don't have any criteria for LiDAR drone acquisitions. Some researchers also do their work with capturing the whole construction site, which is quite suitable, of course, but then you need high-performance hardware to process all the information, which is not so good in my opinion, and also you need complex algorithms to process the data. As we have seen before, the cracks, you need a strong algorithm, so you can say it's a crack. So my main objective is actually a demand-oriented planning, because as a construction company, we know what we are building. We should know what we are building when we are building it. So the wall will be constructed on Monday, for example, and that ensures actually a high data quality and fast information delivery, because I need the information that the wall is constructed, of course, on Monday evening, and not on Friday afternoon. The objectives then of my research are the evaluation and the application of domain knowledge of current construction processes, in particular in bridge engineering, for the UAV LiDAR data acquisition, which will be then event-based and demand-oriented. So the data acquisition will be triggered out of the 4D BIM, because I know on Monday the wall will be constructed. And of course, as a basis, I will use the semantically rich building information modeling with all the information I do have, geometric, but also process information. The planning and the design will then be done by a PDA cycle, so I can make sure all the information I will acquire on site are actually continuously improved and I know what I'm getting from the construction site. These are actually, as you may know, some lean principles. That is the reason why actually the method calls lean data acquisition process, because in my opinion, every data acquisition should serve a purpose and a need of information. So I don't want to just gather information. I want to use the information for a specific use case. Let's get to the concept. Of course, in Germany, it's right now not really possible to have autonomous drone flights due to some regulations, but that would be really nice if the politics are doing their job. So the drone will actually getting the mission from the pull principle out of the 4D BIM, which is the event-based and demand-oriented. So the drone knows where it has to fly and what to acquire. The drone mission will then be planned based on the 4D BIM, because I know in the 4D BIM where my tower crane stands and all the other machineries are and the material. The mission will be then simulated in a realistic virtual environment. The synthetic point cloud will then be validated and evaluated, and if there are some missing spots, occlusions, etc., we will do some adjustment. So we are making sure all the quality criteria are met. Of course, there are some requirements. This concept is only possible if I have up-to-date information from a construction site. If the wall is already constructed on Friday, it doesn't make sense to fly around on Monday in the next week. So we really need the up-to-date information from a construction site and also an object-oriented structure. So it's not linked one process with 16 components. So it really needs to have the same granularity. The data acquisition will be triggered out of the time schedule with some attributes, as you can see here. The duration of the process is quite important, the criticality, the slack. So if I have a buffer time of the schedule, but also some dependency, maybe I cannot acquire a wall, but the slab on top. So I just acquire the slab on top, and I can say if the slab on top is constructed, the wall is also constructed. We do need some navigatable space because the drone has some dimensions, so it needs to fly around within a space. The geometry of the 4D BIM is also quite important. If I don't have any linked objects to the process, I cannot acquire the process. The category, if it's a small or if it's a big component I want to acquire, and also the complexity. For example, an abutment wall can be quite complex if I have some collisions, etc. So this needs to be taken into account. My main message is actually only necessary data is acquired during this process and then will be further processed. The first step of the PDA cycle is then the planning of the drone mission. The waypoints will be determined on the 4D BIM, of course. Level of density and level of surface completeness will be taken into account, but also the velocity of the UAV. Because you can imagine the frequency of the LiDAR taking some point clouds, but you have to take into the account the velocity of the drone, because if you fly slower, you take more data, and if you fly faster, you take less data. The flight path will also be computed on the 4D BIM, tower crane, etc. on the construction site is quite important. The shortest path you can compute doing various search algorithms, battery capacity, but also visual line of sight is also an important requirement. This is how it could look like with global coordinates, because the drone needs geo coordinates and no model coordinates. So this is, for example, if you punch that into Google, you will end up close to Berlin at our pilot project. The next step is the simulation of the data acquisition mission. Here you can see a screenshot with realistic virtual simulation. This is done with Unreal, but we are looking right now into a different software which is much more capable of, because you can then take even into account the tolerances of the GPS positions, which is quite nice. The third step is when the assessment of the synthetic point cloud based on some quality criteria. We haven't developed the criteria yet, but for example, it needs to be use case specific. For progress control, I don't need a really much dense point cloud. I mean, actually, I would just need 4 points to say the wall is constructed. If you can follow the idea. So this still needs to be done. In the last step, an adjustment can be made if the flight parameters of, for example, the data quality are not met by the requirements, if I have too much or too little. And the updated flight mission will always be reviewed again with a PDA cycle. And the whole process actually needs to be done, in my opinion. We need some testing, but I would say maybe for the next 10 projects, and then we are quite confident, and we actually don't need the PDA cycle anymore, because the calculation of the waypoints and the mission are that strong then. Our lean data acquisition process actually helps us ensuring then efficient data acquisition, which can be later then in the outlook be processed. As a conclusion, it's quite a novel approach, because so far all the other approaches, they concentrated on acquire the whole construction site and then have a look, okay, what building components do I see, and match that with the time schedule. But in my opinion, any data acquisition should serve a purpose and a level of information need, which is also a synonym in the BIM language. The data acquisition will then be event-based, initiated, and demand-oriented out of the time schedule, based on the pull principle. The data acquisition will be quality assured, and in my opinion, it is quite suitable for infrastructure projects such as bridge and road constructions, because of the navigatable space. Because a drone, if you have just a building, an office building, etc., maybe you don't have even GNS signal, and the drone doesn't know where to fly. As a quick outlook, what could be done with the Rensic algorithm? We could, of course, then have a look in the point cloud and match the plane fittings with our actually 4D BIM. For progress control, we could integrate the data, and as a larger picture for Freytag, we want to scale up the Lean and BIM-based flight planning, not only for progress control, but also for accounting of our construction work. So we could do the bill of quantities out of the acquisition process, but also the project and construction documentary. We just finished some research where our student was able to update the IFC 4D BIM based on the point cloud, which is quite impressive. And a larger step, if you put then a camera, as we have seen before in the presentation, onto the drone, we could do then some inspection and efficiency management to finish up our construction process. Yes, thank you very much. That was my presentation, and I'm happy to answer any questions.